Hi, we'll understand the sieve of erasthothenes using one example. Suppose you are given a number 15 and you want to get all the prime before 15. So, first thing is you have to run a loop from 1 to root 15. That is, 2 to root 15. So, for this case, root 15 is some 3 point something. So you will take the integer part, so 2 to 3 you will run the for loop. Okay. So for I equal to 2, I less than root 15, I plus plus you will do. Also before doing all those things, you set all the flags for 0 to 14. Means for 15, or not 14, 0 to 14, 1 to 15. Okay, this number. You make like that flag 1 to 15. Okay, this all flag will be high. So when you make a flag high, you are assuming that these all are prime. So initially, assume all numbers are prime. 1, 2 to 2, 3, 4, 5, 6, 7, 8, 9 to 15. All numbers are prime. Okay, that is assumption. When flag is 1, everything is prime. When flag is 0, it's not prime. Okay, so after this for loop, we will run a second loop from I square, I into I, till I less than n. So in the case of 2, the loop will run from 4, 5, 6, up to 15. In this, what we will do, we will put a condition: if this 4 is divisible by j, this will make it as a j is equal to I to I. If j is divisible by I, its flag will become 0. So for numbers 4, 6, 8, 10, 12, 14, we will make flag as 0. So when flag is 0, okay, we don't need to check it again. Okay. Because we already know one time it is divisible by 2, so it can't be prime, correct? So we can only now test other numbers like 5, 7, 9, 11, 13, like that. So inside this the thing, there will be condition if j divided by I and flag is not already 1. So if we already know that till this point, when loop is running for different j's, if flag is already high, means it has never been divisible by something. Then only we will check it. Otherwise we will not check it. So when for first time everything was high, everything will be high, means our flag was high. All iteration of 4, 5, 6, 7, everything will be checked. But next time when I become 3, then it loop will run from 9, 10, 11. But in this 10 will not be checked because 10 already has been crossed here, you see. That is the algorithm. So after running of all this for loop 2, 3 and then for this all inner loop, we'll get all the prime number. Let's see in program how it is done. Okay. So in the program, you are seeing flag as 15, okay. So flag is 15 here. 15 elements flag, and you are setting all the elements of flag as true, means all are high, as I told you before. That means we are in prime. If number is less than 2, then we don't need to check because only one prime is there, that is 2. Now first inner loop will run for 2 to root n, means 2 to root 15 means 2 and 3. And second loop will run from I square till n, means 2 square, that is 4 to 15. 4 up to 4, 5, 6 up to 15. Now these are prints. We can check what is happening in this print, but first we will check the condition. So if j is, these numbers will be j 1 by 1, 4, 5, 6. If j divided by I is equal to 0, means j is divisible by I. And also if flag is already 1, that means you all means when one flag is 1, that means it is prime. We assume it as prime till now. So if flag is 1, then only we will check if it is divisible and then it's prime. Means if it is not already been divisible to something, because flag 0 will only happen when it is divisible by something, right? So until the flag is 1 and your number is divisible by the that 2 or 3, or in that case whatever loop will run, so then only we will make the flag 0. Okay. Otherwise you will not go inside this. So in that case, what will happen? So your 2, 4, 6, 8, all those things are gone. Okay. So because 4, 6, 8 are divisible by 2. Next, or if else it is not divisible by 0 and flag is already 0, then also it is same. This is because, okay, then it will be same as flag because flag is already 0 that time. Now suppose the iteration has gone for I3. So you will have 3 square, so for this j it will run for 3 square, this j will run from 3 square here. 3 square 9, 10, 11. But when you go to this checking condition, because 10's flag already has been made low, because 10 was divisible by 2. So 10 will not be checked. 12 will not be checked. Right? 14 will not be checked. Now 9, 11, 13, those will be checked. So 9 is divisible and flag was already low for 9 because 9 was not divisible. Flag was already high for 9. So its flag will become 0. So now 2, 4, 6, 8, 10, 12, 14 flag will be 0 because they were divisible by 2. Flag will be 0 for those. And for 9 also this has become low. Flag has become low. So except everything of this, flag will be high. Flag high means prime. So in that case, what we will do, we will run a for loop from 2 to that n, okay, and we will put print whichever is prime. So if flag is not equal to 0, means flag is 1 basically, then we'll print which is prime. So if you run this program, one second. If you run this, you will see this will print which is prime. Okay. Ultimately it will print 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime. This print before are like you are checking which flags are going high. So 4, 5, 6 and these are well initially high. Then 10 so when after one run all become others become low and this thing's flag has already been high. That is the solution. Thank you. Hi.